I have a big picture of it.
Okay.
Nice.
Alright. So. Sign this here. Oh, this comes out. There we go. Oh, now we're done. Alright, we would like to introduce you to the glorious Operation Duke Nukem.
Okay.
Alright. Basically, our goals are to fuck this boss's life up. We're trying to do top-tier magic bullshit and bring D&D into the 21st century. Our vision is to create a cataclysmic event that is big enough to destroy an entire city. Now, the form that you might imagine would be a supermassive meteor orbital strike / nuclear explosion.
Okay.
The way this is achieved is through a series of spells that have been pre-cast using subtle spell so that no one could perceive that I was casting them.
Okay.
First off, creation spell. I pull materials from another plane and create any objects up to stone, crystal, or metals. Metals would be the choice in this instance. I'm casting as a 6th level spell, which allows me to make an object up to a 10 by 10 by 10 foot cube. Now, multiple tiers are allowed, and it can be any shape. So let's say in this instance, we'll create a giant shell, if you will.
A big metal bullet, a BMB.
A BMB for short. Now, the spell duration is 1 hour, so we'll have plenty of time to get this under wraps. Next is the teleport spell. You can instantly transmit 8 willing creatures or a 10-foot cubic object. Now, being that the bullet is within the 10-foot cubic object, easily teleported to any place that I know, period. Now, we've been sitting in the city for a couple months. I've been studying the lay of land lay around us. I've seen the temple there every day. I know this area very well. So I will teleport this object to the atmosphere above the temple. Now, first you might be wondering, how do we strike the temple?
Right, so, when it comes to guidance, there's a couple things we have to take into account here. First off is wind velocity. There's a jet stream, approximately 125 knots, plus or minus 25 knots, roughly 12 kilometers up into the atmosphere. Now, 125 knots is approximately 64.3 meters per second. Wind force on an object is dedicated for this equation here, 1/2 rho v squared times the surface area which it's acting on. Now, the force of the wind, in this case, is 1/2 times 0.19, which is the density of the atmosphere at 12 kilometers, times 64.3, which is going to be the density of the lead that we're using, times velocity, 6.3 meters per second, squared, times the surface area that this will be acting on, which is 8.29 meters squared. Now, the force of the wind is going to be 71.93 pound-feet. Seeing as our lead block will weigh significantly more than this, wind will not be a factor in our guidance today. Slide. Now, the second guidance, Earth's rotation. Now, the Earth rotates at approximately 1,600 kilometers per hour, or 444.44 meters per second. And the reason we know this is because there is 36 ley lines located all around the Earth, and approximately every 40 minutes the sun's directly overhead. So using that calculation, we can get to the approximate of 444.44 meters per second, thanks to Cynthia's telemetry in her brain. Though we've also confirmed, because we have said on multiple occasions, that she is good at trigonometry. It's going to take approximately 123 seconds to fall from space, and we made it so approximately turn 6 or 7 after we cast it that this would occur as a direct impact. Now, the distance it's going to fall, or the distance the Earth will rotate, is just a simple equation. It's going to be the speed at which the Earth rotates times how long it's going to take to fall to get about 54,000 meters. So as long as Alphonse knows that it's going to take, he's got to spawn at approximately 54,000 meters up at 75,000 kilometers in the atmosphere, then it'll rotate perfectly to the boss's lair. Slide.
Now, you might be wondering, why lead? Now, lead is a high-density material, meaning that we're trying to get the maximum weight we can and crushing force when it comes down and impact the ground. In addition, it has a high melting point of 325.5 degrees C, which means that even including the friction of the atmosphere as it's coming down, it'll heat up to a temperature below that, 100 to 300 degrees C. So the lead will not melt coming down, and we won't have to worry about it disintegrating in the atmosphere.
Slide.
Slide.
And now let's get into the math, the meat portion of this. So, total energy. Kinetic energy is equal to 1/2 mv squared, if you remember from your physics classes. Now, let's start with the mass. We have two unknowns here, mass and velocity. For mass, we take the rho, or the density of the lead, which is 0.409 pounds per inch cubed. Converting that to feet cubed, we get 706.752 pounds per foot cubed. Now, mass is equal to density times volume. Here we have some simple equations based on the volume of the cylinder and the volume of the half circle. I'll just go ahead and let you do that. I'm not going to explain it. And then we get the mass of the object. It's going to come out to about 462,474.3 pounds. Converting to kilograms, because metric is always better, is going to be 209,774.81 kilograms. Now the second unknown, velocity. Velocity is equal to acceleration times time. Now with no air resistance, we're going to go ahead and assume that the terminal velocity is just equal to the 9.81 meters per second squared times the time it takes to fall from space, which is going to be 142.86 seconds. So we get a total here of 1401.46 meters per second as terminal velocity. But unfortunately, we have air resistance, so it's going to go a little slower. And the equation is a little more complicated. So here we have the equation for terminal velocity is the square root of 2 times mass times gravity over the density of the material over the surface area it's acting and the coefficient of drag. Now, we already explained all the other equations here. The coefficient of drag for a bullet is approximately 0.3. And so we get, after doing this equation, the terminal velocity of 1120.098 meters per second, which will occur at approximately 75,000 meters.
Thus, by creating it in a bullet shape, we'll be able to minimize the air resistance on the bullet, increasing the maximum velocity we can attain.
Mm-hmm. So, when it comes to energy, we have all our equations now. We'll plug them into the formula, and we get approximately 0.1316 terajoules, or 0.032 kilotons of TNT. This is 1.5 times more powerful than the Davy Crockett nuclear warhead currently in the United States arsenal. Now, we established that 2 ounces of gunpowder is 1d6. 8d6 per pound. 0.032 kilotons is 32 tons of black powder. 32 times 2,000 pounds per ton is 64,000 pounds of black powder. Now we get about 8d6 per pound, so 64,000 times 8 is 512,000 d6 at ground zero, which is within 20 meters, and that's plus bludgeoning if hit.
Let's not forget, it's only plus bludgeoning.
Plus bludgeoning, yes, naturally. Now, if you're within 70 meters, the shockwave will hit with 20 psi, which will cause destruction of almost all buildings and a near 100% fatality rate. The average D&D NPC has roughly 17 hit points, so to get a near 99.999 chance of death, you'll need to do 1 16 times with a D10, which is a typical thunder damage kind of thing. So a 16 D10 will work here at 70 meters. Now from 70 to 150 meters, the shockwave will be at roughly 5 psi. So it's a quarter of the damage of the previous. We're going to do 4d10 thunder. Because everyone knows thunder is a sonic force. Now, at 160 meters, we have a 100% chance of third-degree burns. So third-degree burns the entire body. It's not necessarily fatal, but will probably bring you to 1 hit point. The average dice roll must equal 16. So average die roll is equal to the max die roll plus 1 divided by 2 times the number of the same dice. So to get 16, we just do the simple equation of 16 equals 6 plus 1 over 2 times x, which is what we're looking for here. So we solve for x, and we get roughly 5d6 fire damage in addition to previous damages at 160 meters. Now at 370 meters, the shockwave will be kind of piddling out at this point. It'll get to 1 psi, so it's pretty easy to do as just 1d10 thunder damage. Now to get the in-between damage, we will need to interpolate.
Now, this is a good demonstration of what the nuclear map would look out at ground zero. As you can see, at ground zero, we have the fireball radius, which is roughly 20 meters. That's where we're going to be doing most of our damage. It's going to be 512,000 d6 worth of damage, scaling down from there to the next radiuses. Next is the sonic blast radius, which was causing all the shattering of all the buildings, destruction 100% of the surrounding area. In addition, you have the air blast, which is going to cause most windows to blow out, and a larger radius to destroy all other major fractal structures. In addition, we have the thermal radiation caused by the impact at ground zero, as well as the pressure wave. These demonstrate the 20 meter, 70 meter, 150 meter, 160 meter, and 370 meter radius of the blast zone.
Now really what we need to do is figure out how does that apply to our boss. What if he lands right here in the center? Well, we created a handy graph for that. Slide, please. Now for scaling. Now here we have 2 different lines. One is thunder damage as plotted by the green line, and then one is fire damage as plotted by the pink line. Now, at ground zero, which is within 20 meters, it's going to do maximum damage. So it will be approximately 325,818 d10 thunder damage plus 512,000 d6 fire and bludgeoning damage. Now, as fire damage piddles off, we know that at 160 meters, it does 5d6. So we just plot this graph, and we get that every meter is 3,657.14 d6. So at 159 meters, he'll be doing 3,662.14 d6 fire damage. Now, when it comes to thunder damage, a bit more complicated, a few more points. Early on, it's going to be very powerful, very powerful decline, I should say. And from 20 to 70 meters, we will have a reduction of 6,516 d10 per meter. From 70 to 150 meters, we only have a reduction of 0.15 d10 per meter. And then from 150 to 370 meters, we have a reduction of 0.014 d10s per meter. So, in short, if you're within 160 meters,
In order to achieve in final conclusion, in order to achieve what we're looking for, we created an object, teleported it up, accelerated to terminal velocity, create a guidance system for it to impact the boss. Right before impact, we ourselves teleport out of the way to avoid any damage and leave the entire area totally fucked. You are fucked.
That's the best thing I've ever
do you have any questions?
Yes. Did you roll to hit?
Oh, as long as we're within anywhere between 370 meters, we don't really need to roll to hit. You will get hit.
Okay. Just for fun, roll to hit.
I cast Wish. My level 9 spell that you gave me because you leveled me up to level 17.
Mm-hmm.
I wish that the boss was perfectly hit and did not resist or was immune to any of the damage types.
In addition, the whoopee.
In addition, the whoopee will be destroyed.
So, what happens? That's the big question. So, what happens? You all gather together, getting ready to get out of this big fireball explosion that you know is coming. Luckily enough, you are all together. You grab Trieg's dead body just because you love him so much, and he would be buried in this wonderful garden. Do you make any final gestures?
Make sure you wish that we can teleport out of here before he says anything previous to that.
No. Do you make any final gestures to the lich?
If I had to make a final gesture to the Lich, I'd be out. See ya!
Perfect. You are able to do so.
Yeah!
The Lich looks down in confusion as his people leave, knowing that this should not be a spot that you can teleport out of, but for some reason their magic has gone beyond the capability of his own. He feels something coming, but he does not know what it is. And before he can even look up to see the impending crushing of his ceiling coming down upon him, everything just disappears. Please roll for damage.
All right.
It can't go that high.
We tried.
The entire area of the entire castle is incinerated in a beautiful, dazzling light.
Nuclear hellfire.
Absolutely destruction. The earthquakes over miles. People in the near town are scared and frightened at this large, bright cloud, which could be only described as a mushroom popping up off the ground into this cloud of death.
Because of Trieg, of course.
Naturally. After this moment, you are all whisked away and safe, popping back into...
We're going to teleport so we can get a nice view of it all the way back from the town in a nice, safe area.
At the very, very back of the town of Narshamara, there is a nice little cliffside overlooking what you would see as the dreaded castle miles away.
Which you cannot get to by boat, by the way.
You cannot get to by boat. You are whisked away there, and funny enough, it seems like someone there with a cloak and a staff over his shoulder has made sure that there are some very comfortable chairs just lined up on the sides.
That's good, because
You're
I
all
have a jeweled cup and 8 glasses of whiskey that I can also drink.
Yeah, my moonshine and my silver goblet.
They are all sitting there ready and waiting as you see this beautiful, dazzling white light destroy this entire area. And then all of it collapses into this dark little ball, and the ball cracks and shatters. And the whoopee has been destroyed. As for you,